Okay, hello everybody. Welcome to video 2. So question number 3. Use the table of the rational function. So we're told this is a rational function to find the following. So looking at this table real quick, I see I have an undefined value at -3. So this -3 is an excluded value. So it's got to be a whole or an asymptote. So let's see what we got here. This says find the limit of the function as t approaches -3 from the left. So as we're looking, so from the left, so if you look at this number line, sometimes if you want to get fancy, you can turn it sideways. But this number line, so that's where -3 be on the number line. This is getting closer and closer to 3, so -3.1 is smaller, so it's on the left side of it. So the left side is up over here, and the right side is over here. So as we approach from the left, let's see if I can color code these. So from the left is what happens as I'm approaching 3 from this direction. From left. A better L. So -3.1 is pretty close. 0.01, that's getting closer and closer and closer. And I can see that this is getting larger and larger. So 19, 199, 1999, 19,999. These numbers are jumping up bigger and bigger and bigger. If I were to graph this, so let's say this is the graph, and this right here, we'll say this is x equals -3. And I kind of plotted these. So -3, 19 will be up here. And then this is a little bit closer. It's going to be 199, so it's going to be much higher. This is going to be much higher than that, and this is much higher than that. You can kind of see it's approaching infinity. So this should be going to positive infinity as we approach 3 from the left. So right here, find the limit of the function as t approaches -3 from the right. So from the right is going to be from this direction. We're kind of reading the graph backwards here, so this is from the right. And so -2.29, so -21, so that's going to be below the x-axis right there. And this is a little bit closer to -3, so I'm going more right this direction, and that's going to be much smaller, it's much smaller because it's negative, and then a much smaller, and so this one's also going down to -infinity. But we can see it's getting closer and closer, or closer and closer to -infinity. So this tells us this is definitely a vertical asymptote. They're not going to the same number. So as t approaches -3 from the left, d increases. You could say something like increases without bound, or you could say approaches -infinity. And then as we approach it from the right, we're going to -infinity, so we could say that this decreases, the function decreases without bound. So it goes to -infinity. Okay, next, use the binomial theorem to expand the following. So this is just binomial expansion. This is the 5th power, so I want to use the 5th layer or the 5th level of Pascal's triangle. And the 5th level is, if you have it memorized, great. If you want to draw it, fine. Let's draw it once. So let's do this be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1. So the 5th layer, so we're going to be using this one right here. This is the 5th level. The 5th level, 1, 5, 10, 10, 5, 1. So these will be my coefficients. And then I need to do, so let's write the I don't usually write coefficients first, but let's do that first. So the coefficients are going to be 1, and then we'll have plus 5, and we'll have plus 10, plus 10, plus 5, and then a plus 1 over here. Now I need to do the the a and b here. So we start with this first term of the binomial. We'll start right here, and we'll start with the highest power that we can give it. So we can multiply a to itself 5 times, and that uses all 5 powers. We can also multiply a to itself 4 times, but if I do that, not a, this should be x. I'm sorry, that should say x. We could also multiply x to itself 4 times, but then we need to make sure that we also that 3. So we'd need to 1 3. So these should add up to 5. So 4 x's and 1 3. This next one would have 3 x's. But if I have 3 x's, I should have 2 3's. I could also have 2 x's. But in that case, I would need 3 3's. I could have 1 x, but if that was the case, I would then need 4 3's. Or I can have 0 x's. In that case, I would need 5 3's. And then we're not done yet. We have to multiply them all out. So here, x to the 5th, there is nothing really to simplify there, so that is just x to the 5th. Here I have a 3 to the first power is 3. 3 times 5 is 15. X to the 4th. Bring that guy down. 3 squared is 9. 9 times 10 is 90. So this should be 90x to the 3rd. 3 to the 3rd is 27. 27 times 10 is 270 x squared. 3 to the 4th is 81. 81 times 5 is, so that's what, 400 plus 5, so 405 x. And then finally, 3 to the 5th is just 81 times 3, which is 243. And there is the expansion. Now this one asks us just to find the 5th term of this polynomial. And this is to the 7th. To the 7th. So we need the 7th row of Pascal's triangle. If we extended the 7th row, if memory serves, you can always extend the triangle you made here. But if memory serves me right, it should be 1, 7, 21, 35, 35, 21, 7, and 1. And so I should have 8, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And now I just want the 5th term. I don't need to expand the whole thing out like I did here. I just need the 5th term. So the first term would be this one. This would be the 2nd term. 3rd, 4th, 5th, 6th. So, the 5th term. Yeah, we need the 5th. So 35. 1, 2, 3, 4, 5. 35 is going to be my coefficient. So the 5th term should be 35 times. And I'm going to need to, that's a 2x, so I'll put a 2x right here. And this other one's going to be a -1. Okay. So now I need to figure out what my exponents are going to be. Now the exponents are going to add to 7. So let's figure out what this first one is. So the first term, this would be x. This would be this first one to the 7th, to the 6th, to the 5th, to the 4th, to the 3rd. So this should be 2x to the 3rd. And then this is what? This is this one to the 0th, to the 1st, 2nd, 3rd, and 4th. So this one should be -1 to the 4th power. So this is the 5th term. So this is everything associated with that right there. The powers and the coefficient. So now we just need to simplify. 2x to the 3rd is going to be 8x to the 3rd. And then Negative 1 to the fourth power, well, that is an even power. A negative number to an even power is going to be positive. So this is just going to be times 1 and 35. So now I'm almost done. I just got to simplify this last part, which is just the 1 doesn't matter. 35 times 8. 8 times 3 is 24, so that's 240. Plus 8 times 5, which is another 40, so it should be 280, I believe. Hopefully my mental math didn't fail me there. But 280x to the third. Okay. Next up. Some transformations. So graph these transformations from the graph. So here I have a negative f of x minus 2. So this tells me that this part on the inside, so this is a horizontal transformation or translation, and I'm going to be adding 2 to all the x's because the inside works backwards. And then I also need to, this is a vertical dilation, or actually a vertical reflection, so I need to reflect over the y-axis. So I need to make every y value multiplied by negative 1. So here, 0 times negative 1 that stays the same there. But then I need to shift everything 2 to the right side that doesn't make the L. So 1, 2. So my first point should be right there. This next one, it flips. So it goes from a positive 2 to a negative 2. And then it translates over to 1, 2, right there. This next point here flips down and then shifts over 2 to the right. And then here stays the same because 0 times negative 1 is 0. And then I shift right 2 again. So that ends up being like that right there. Okay, next up, this one. So this is a vertical dilation. So we're going to multiply all our y values by 2. And this is a vertical translation. So we're going to subtract 4 from all our y values. And because this is on the outside, PEMDAS is normal. So we'll do the multiplication first and then the subtraction. So right here, and then x values don't change at all. So the x values will stay the same. So here at negative 2, it's going to multiply by 2, so that becomes negative 4. And then we're going to go down 4 more. 1, 2, 3, 4. So then we'll go right here. 3. 3 is times 2 is 6, so we'll go up to 6, and then subtract 4. 1, 2, 3, and 4 to 2. And those two dots connect. Right here, I'm going to multiply by 2 to get 6, and then go down 4 to right there. And then here at 5, 1, 1 times 2 is 2, and then down 4. 1, 2, 3, 4. There we go. So that is twice as big and shifted downwards. And last on this page, here, this is so this right here is on the inside, so it's a horizontal dilation by 1/2. We got to do it backwards, and then we're going up 5, so we'll add 5 to each of the y values. So here, my x value is, that looks like it is negative 5. Half of that is negative 2.5. And then I'm going to go up 5 units. So 1, 2, 3, 4, 5. There's that first point. The second point is, so let's go right here. I go times, so negative 3 times 1/2 is negative 1.5. And then I go up 5. 1, 2, 3, 4, 5. So right there. And then here, negative 1 times times 1/2 is 0.5. 0.5 plus, then 0 plus 5, it goes up here. So there is my that little cup part. It's been squished horizontally. Next point is right here. So that's 2, half of that is 1, and then up 5. So we're at 3. We should go all the way up to 8, and it should be just like that. And page 2 is good as done. I'll see you guys in video 3.